All right, graphing secant. So here we go. Remember, secant is 1 over cosine of theta. And so let's graph cosine of theta and get kind of get a reminder of what this will all look like. So cosine, again, just this nice rolling wave, um, and 1 over cosine, that can't be too bad. And obviously, if you watched the last video, you saw that tends not to actually be true. This one's going to be pretty interesting as well. And so pi over 2 pi and 3 halves pi and 2 pi. And over here, negative pi over 2, negative pi, negative 3 halves pi, and negative 2 pi. And let's start by graphing. Let's just graph cosine and to help us out. So at 0, cosine is 1, and at pi, cosine is negative 1, and back to 1 over here, negative 1. Just trying to give myself some reference points so that my graph isn't too terrible. And there's cosine. And there we go. Now, let's start by thinking, okay, well, and plugging in some values that when we invert them, so have 1 over cosine, that will be, okay, just see what we have. So at 1, what's 1 over 1? If we plug in 1 as cosine right here, that's going to be 1. So we'll have 1 over the value of cosine at 0, which is 1. So 1 over 1 equals 1. There's that point. There's the that's going to be part of our secant graph. Let's go to all the way to pi. If we have 1 over, or a cosine value, and our cosine value is negative 1, that gives us, well, 1 divided 1 is negative 1. So that's actually going to be the same value there as well. And so notice that's happening at negative pi, at negative 2 pi, and that those points are actually the same on each graph. But from there, things are going to change a little bit. So if we have 1 over, now let's find out when cosine is 0. So where is cosine 0? Here at pi over 2. So if we have 1 over 0, that's going to be undefined. That's going to be one of our asymptotes. And so here, let's go ahead and sketch that in. If we go 180 degrees more, or 1 pi more, we're at 3 over 2. Again, cosine is 0, so we're going to have 1 over 0 again, another asymptote. And what else is cosine 0? Negative half a pi and negative 3 halves pi. So we're going to have some asymptotes here. Now, this would be different than our tangent and cotangent graphs. So let's think about this a little bit. If we're heading closer and closer and closer to 0, but we're still on the positive side, if we're still on the positive side, these are going to be more and more and more positive. So our graph's going to curve up, head towards positive infinity, head towards positive infinity. On the left side, so left of here, but still approaching the asymptote from the positive side, cosine is heading towards 0 again, heading towards 0, but it's still on the positive side. So our 1, from inverting it, is being divided by smaller and smaller and smaller positive pieces. So this is actually going to head up on this side as well. Okay, we'll have this little U shape here. Now, once we get past our first asymptote, we have now 1 being divided by, for example, looking at this, we have 1 being divided by smaller and smaller and smaller negative pieces. So as 1 gets divided by smaller and smaller negative pieces, our output is negative and heading towards negative infinity. Likewise, if we head over to right here, where pieces are getting smaller and smaller and smaller, closer and closer and closer to 0, but they're still negative, we're going to divide it into smaller and smaller and smaller, or into greater, higher and higher and higher negative numbers and heading towards negative infinity. And notice kind of that repeated U shape as it goes on and on and on throughout your graph. A quick way to remind yourself of which side it's going, that is, if your value of cosine is positive, it's going to be heading towards positive infinity here. And if it's negative, it's going to head towards negative infinity. All right, so let's go ahead and through and figure out our different pieces about our graph. So hopefully, I don't know, I think it's a pretty interesting looking graph. If you graph that on your calculator, so let's go ahead and throw that in. So now y equal to, let's not graph cosine right now, just 1 divided by cosine of x, or cosine of theta. Graph that. And there's your graph. Now notice it's graphing in the asymptotes. They're not actually part of your graph, so those lines wouldn't be there. It's just the U's, the U shape there. And if we had both of those together, as you can kind of see in the sketch here, they fit together kind of in an interesting way, that they touch there at their, I guess it's their vertices. And yeah, just it's a neat little pairing, I think. All right, so period. What is the period of it going to be? Well, be careful. It's not just a period of pi, because that would only include the positive infinity. We need to go 2 pi to get negative infinity as well, and then it repeats after that. So maybe from positive 1 to positive 1, that might be the easiest way to think of what's our period. So from 0 to 2 pi, 2 pi. The amplitude, again, its maximum value is infinity, and its negative, its minimum is negative infinity, and those aren't numbers we can really use, so its amplitude is none. Domain, we can't plug in the value of pi over 2, so theta cannot equal pi over 2, or 1/2 pi, and then every n times pi thereafter. Or if we had this in degrees, theta could not be equal to 90 degrees, and then every 180 degrees after. All right, its range. What's its range? Well, it's not going to be all real numbers. Notice you can't get a secant value between -1 and 1. Those values aren't ever on our graph. They're not part of our range. And so y is going to be greater than or equal to 1, and y is going to be less than or equal to -1. So greater than equal to 1, or less than or equal to -1. So knowing all that, give your hand at graphing cosecant. Not going to have a video on it, but really highly recommend that you start by graphing sine and then kind of reason your way through just like we did here. So, all right, best of luck to you, and hope that helps.